Welcome to the video on the preparation of a standard solution. In this video, we will show you how to prepare 50.00 ml of a sodium acetate solution with a concentration between 0.1 and 0.2 molar. How much sodium acetate is needed to make a solution with a concentration between 0.1 and 0.2 molar? Let's do some calculations. Here's the datasheet and the formula that we need to calculate the target mass of sodium acetate we need to weigh out. The molar mass of sodium acetate is required. It is 82.0338 grams per mole. Putting in 0.1 molar for the concentration of sodium acetate and 0.05000 liter for the total volume of the solution, the amount of sodium acetate required to make a 0.1 molar sodium acetate solution is about 0.41 grams. Making a 0.2 molar sodium acetate solution requires about 0.82 grams. Therefore, we will aim to weigh out a sample of sodium acetate that is between 0.41 and 0.82 grams. At the balance, using the techniques of weighing by tairing, our sample of sodium acetate has a mass of 0.6827 grams. Let's prepare the solution. Obtain the glassware needed, a volumetric flask which will hold the final volume of the solution. Since the final volume we are aiming to make is 50.00 ml, we will need a 50 ml volumetric flask. A 50 ml beaker which will hold approximately 2/3 of the volume of the final solution. We will use this beaker to dissolve the sodium acetate we weighed out. First, we will need to transfer the sodium acetate from the weigh boat to the beaker. We use the technique of quantitative transfer to ensure the entire sample is transferred. We pour the sample from the weigh boat into the beaker. Then, using a water bottle filled with distilled water, rinse the weigh boat thoroughly. Pour the rinse water into the beaker. We repeat the rinsing 3 times. At this point, the amount of distilled water should be about half to 2/3 the solution volume. Using a stir rod, stir until the solid sodium acetate is dissolved. Inspect the beaker closely to make sure no solid is present. Rinse the stir rod thoroughly before placing it down on the bench. Pour the solution from the beaker into the volumetric flask. Note: a small funnel may be used if you are uncomfortable with pouring from the beaker. Follow the steps on quantitative transfer and transfer the solution from the beaker to the volumetric flask. Note: if a funnel is used in this step, the funnel must be rinsed 3 times. All the rinse water must be poured into the volumetric flask. At this point, the amount of distilled water should be about half to 2/3 the solution volume. Swirl the flask to mix the solution. Bring the level close to the mark and allow time for draining. Then, use a pasture pipette to bring the level of the solution to the mark with more distilled water. Do not immerse the tip of the pasture pipette into the water bottle. Use a small clean beaker to transfer more water into the volumetric flask. Bring your eye to the same level as the mark on the neck of the volumetric flask and fill the volumetric flask such that the bottom of the meniscus touches the mark. Firmly stopper the flask and invert repeatedly, at least 15 times, to assure uniform mixing. After mixing, remove the stopper, allow time for the solution to drain, and check that the bottom of the meniscus is still touching the mark. Let's calculate the actual concentration of the solution. Recall the mass of sodium acetate weighed was 0.6827 grams. The concentration of the sodium acetate solution is obtained by dividing the mass of sodium acetate by its molar mass and then dividing by the total volume of the solution. The calculation tells us that the actual concentration of the sodium acetate solution is 0.1664 molar. As the last step, we put a label on the volumetric flask to indicate that the standard solution we just made is a 0.1664 molar sodium acetate solution. Thank you for watching the video on techniques to prepare a standard solution.